Hey class, welcome to the second lesson of 2.1. This is called Functions, Domain, and Range. Again, what I have here is I have a target for you to think about for the lesson. So let's get to it. Reminder, a relation, any pairing of two number sets to make any ordered pairs, so any data plot, and a function is a relation where no two ordered pairs have the same first x-coordinate. In other words, the input can have one and only one output in the y-coordinate. So just a quick reminder of what a relation and a function is. And also, today we're going to figure out a very quick, easy graphical way to determine whether something is a function. And it's called the vertical line test. So if you have the graph, like I have here below, instead of a table of values, how can you tell if it's a function or a relation? All right, well, think about all the coordinates that we have there. All right, so if I were to label my different points, okay, I would have -1, 1, I have -2, 3, I would have 0, -1 right there, 1, -3, and then 2, -5. Okay, looking at those numbers, clearly you can see none of the x values are repeated. All right, -2, -1, 0, 1, 2. None of those have repeats. All right, now labeling all those points kind of took a little bit of time, and that was kind of a lot of work. How can I do that? So I can use what's called the vertical line test. All right, so think about any vertical line, like there's one right here, this vertical line. All right, if that is a function, no part of the graph can cross that vertical line twice, and it's anywhere. So if I put a vertical line here, if I put a vertical line here, if at any point the graph crosses a vertical line twice, then it is not a function, therefore it would have failed the vertical line test. Okay? It's a very easy way to look at a graph and determine if it's a relation or a function. So let's take a look at some examples of that. Looking at these four options, which ones are functions, which ones are not functions. So thinking about a vertical line, all right, if I put that vertical line down there, and then can I move it back and forth? Are there any ways in which that graph crosses that line more than once? And since the answer is no, it then is a function because it has passed the vertical line test. So in part A, the answer is yes, it is a function. Why? Passes the vertical line test. So make sure you know how to explain. The second one down here for part B, we'll take a look. If I draw that line right there, then does it pass? Look at almost everywhere I draw it right now, it crosses that vertical line twice. All right, pretend that's just a single line. So then this answer is no, it is not a function because it's just a relation. Part C, does it pass the vertical line test? So I'll draw a vertical line. Let's see if I can move it. At any point, does it, oh, right there. There it hits the vertical line twice. So right there, sorry, I gotta get right there and right there. Those are two dots on the same vertical line. So then the answer is no, it's not a function. And then on part D, if I draw a vertical line, does it pass the vertical line test? Yes, it does. Therefore, that is a function. So yes, it is a function. So vertical line test, very easy way to determine graphically whether something is a function or not. Changing gears to another idea. Next, we're going to look at what's called domain and range. And domain is when you have all possible, not when, but domain is all possible inputs or x coordinates of the given function. Whereas range, what do you suppose range has to be? That's all possible outputs, all right, or y coordinates of the given function. So I want you to look at parts A, B, C, and D, and I want you to try to think about what is the domain? What are all possible, so all possible inputs of the domain, and what are all possible outputs of the given function? So try A, B, C, and D here. Write the domain, So I'll give you a hint. To do domain, you can simply write a D and then a colon, and then usually you use set notation. So set notation are these squiggly brackets, all right? If you're not a fan of the squiggly bracket, then instead, when you write domain or range, you could use a square bracket if you'd rather use that. But then just state the domain, state the range for all 4 of these. So try that real quick. Pause the video, please. Try these 4, and then play it again, and I'll come back to you. All right, so for part A, the domain would be the x value. So there, and there. So the domain is -3, comma, -1, comma, 2. And then you would close the bracket. Again, if you don't want to use the squiggly bracket, you can use the square bracket. But since I started with squiggles, I got to end with the squiggle. So then the range is the y. So y, y, y. Now here's actually what you do. If you wrote down 0, 1, 4, because that's numerical order, you would are correct. You always write them in least to greatest order, no matter what list, however order they're in when they see the ordered pairs. Okay, so I'm going to follow that. I'm actually going to go over to part C here, and I'm going to write the domain here. And this domain is the x values. So if you take a look at it, it's -3, -2, -1, 0, and 1. That is the domain. The range, however, how many numbers really are in the range? 2, 4, and 6. So don't ever repeat items in the range or the domain. All right? So that's an easy way, that's another way you can tell whether something is a function or not. If you have repeats in the domain, sorry, or my color scheme, if you have repeats in the domain, then it is not a function. But if you have repeats in the range, that's okay. That still makes it a function. But only write the numbers in domain or range. You write the numbers in numerical order without repeats. And just to make it easier, because it's very similar, I'm going to go right down here to part D. The domain would be, if you like the square brackets, 0, 1, 2, 3, and 4. And then, so again, numerical order, least to greatest. The range is then 1, 2, 3, 4. Now I saved part B for last because it's different. Now on part B, if you wrote down simply the domain as -2, -1, 0, 1, and 2, all right, that's a good start, but you missed the fact that these points are connected. So it's actually every number between -2 and -1. Everything, including those numbers and everything in between. So it's a line that goes on forever. So think about this. How far to the left will this graph actually go? All right, that's how you figure out domain. How far to the left will it go? Well, the domain in this case will go all the way to, what do we call the number all the way to the left? It goes on for an infinite amount, but if I go to the left, that would be a negative infinity. And then that's less than or equal to x. And then how far this way on the x-axis will a graph go? And that's going to go all the way again until positive infinity. So that is the domain. And then the range would be, well, how far down will it go? It's going to go down until when? And then how far up will it go? Well, the range is going to go down all the way until, sorry, that was a terrible bracket. That's a reason a lot of you don't like those. I get it. It's going to go from negative infinity to positive infinity, but this time I'll use y in there, okay? And that's the domain and that's the range. Now there is another way that you could write this. What's another way to describe every number from negative infinity to positive infinity? And those are called all real numbers. So you could write out all real numbers, and that could replace what I have here in the squiggly brackets. The other way you could do that is there's a symbol. If you've remembered, there's a symbol for all real numbers. You could simply write that symbol, which is a double barred R, kind of like the double bar P for paragraph, but that's called all real numbers. That is the same symbol as writing out these words as also writing out this inequality. Okay, so that's domain and range, and there's some examples. All right, switching gears one and final last time, and now we're going to talk here about function notation, you can see. And if y is 3x plus 9, what is y when x is 4? Okay, a lot of writing there, big sentence. Function notation actually makes this question easier and makes your work easier, I believe. Okay, so function notation is actually easier. So instead of having y equals, some of you might remember that we have the notation instead of a y, we can use function notation, which is f of x. Okay, and so I could write that this way, right here. So take a look at what I have here. There's f of x. Again, writing this out, this stands for, how you say that is you say it as f of x, that's how you say it, equals 3x plus 9. Now take a look at what I have up here. Y equals 3x plus 9, and f of x equals 3x plus 9. All right, it's the exact same thing. The y was simply replaced by the f of x. So the exact same thing, but it's a lot easier to write, and your next couple classes, especially next year, and if you get to calculus, it's extremely important to know this function notation. Now, take a look at this sentence down here. Okay, I just wrote f of x equals that, and now I'm asking for f of 4. All right, so this down here, I'm going to clean this up. I'm going to erase this. Okay, I'm going to clean this up a little bit so it's easier to see. This sentence right here is the exact same thing as this sentence up there. So when I'm looking at f of 4 here, f of 4 simply means what is y when x is 4? Okay, so take a look. Notice I had f of x. It's now f of 4. So really what that means is that x equals 4. So I'm just going to take 4 and plug it in for x. So I'm going to write 3, and instead of x, I put parentheses, x plus 9. And that means I put the 4 inside of parentheses. So that's just, again, f of 4 means x is 4. I plug in a 4 into the x value and solve for y. And so f of 4, well, this becomes 12, and plus 9 would equal 21. So really it means 21. Now I'm going to write this in a better spot and a little cleaner. So my answer is f of 4 equals 21. Okay, now this is so much information right there. This tells me x was 4 and y is 21. So that gives me the coordinate 4 comma 21 in the answer by writing it out in this function notation way. Up here in blue, you would have simply found the answer to be y equals 21, and then that's your answer. Now I only have half the amount of information. I have only the y value, whereas down here, I have the x and the y value by using function notation. That's why it's very important. And it's actually a lot easier, and we're going to use function notation a lot this year, so we're going to get you set up on it right now. So take a look at this problem here. Try a few of these. So if you look here, I have f of 3. Well, there's f over there. I then have g of negative 2. Well, g is right here. All right, so you don't always have just f of x. Right here in red is g of x. And then here is h of x. So try these, where there's h right there. All right, so try these, and there h again. Try these here, and pause the video, try these for a second, and then come back. All right, hopefully you've had a chance to attempt. And so to find f of 3, I got to use the f function, which is 3 divided by 2x. All right, so that really means I'm going to take f of 3 will equal, so the number is 3. All right, so I'm going to write 3 over 2 parentheses like that, and in the parentheses I put the 3 again. Okay, Now that's just going to become 3 divided by 6, which is going to be 1/2. We will write our answer as 1/2 and not as 0.5, please. So use the fraction whenever possible. All right, we're going to move on to g, and g of -2 means I'm going to take -2 multiplied by -2 and minus 4. All right, if you like to, you can add the opposite if you prefer that. All right, and then that's going to become, 4 plus -4, which would equal 0. All right, having that negative inside of parentheses right there, make sure you multiply the negatives correctly. So then the answer there is 0. So you want to write your answer as the entire function answer. G of -2 equals 0. Don't just have your answer be 0, okay? I want you to have the full function notation, the full function work in your answers, please. Moving on down to the next one here, h of 5. So h of 5 is going to be 2 multiplied by x squared minus 4. And I put 5 in there. So this is extremely important with the exponents. Remember, our order of operation is PEMDAS, okay? Which means I do parentheses, then exponents, then multiplication or division, and then I do addition or subtraction. So that means I'll do what's in parentheses first, which is the 5, and I can't do it with 5, so then I square it, so that's 25. Then I multiply by 2 and subtract 4, so then that's going to be 50 minus 4, which would be 46 is the answer there, 46. And now to do the last one, h of -2, this is extremely important. Here's the importance of the parenthesis. I put -2 inside of parentheses. Now the parentheses happens first, so I have a -2 and I square it. Now a -2 squared means -2 by -2, which is going to get me a positive 4. So 2 by 4 minus 4. Okay, that's going to become then 8 minus 4, which is 4. All right, that's extremely important. If you type -2 squared into the calculator will output -4. If you type in parentheses -2 squared into the calculator, it'll output positive 4. This isn't wrong, this is correct, because what I have right here, all right, order of operations, parentheses is first. There are no parentheses here. What's the next thing? Exponents. The exponent is going to be right here. It's just 2 squared. Then it's multiplication by the negative. So 2 squared is 4, and then multiplied by negative is -4. Or you could look at this as it's -1 multiplied by 2 squared is really the order of operations. Or you could look at it as it's the opposite of 2 squared. What's 2 squared? 4. What's the opposite of 4? -4. Okay, so that's a quick exponent and parentheses rule. All right, I'm going to clean this all up before I move on to the next thing. All right, I got that cleaned up. Now I'm going to move on to part E. I'm going to find x if f of x is equal to 1/12. Okay, well remember what f of x is. F of x is 3 over 2x, and that's going to equal 1/12. So really this is what I put in for the y value. Okay, and then now how do you solve a fraction next to a fraction? And what you do there is, again, it's called cross multiplication. We multiply there, so 3 by 12, all right, that is 36, and 1 by 2x is 2x, so it's 2x equals 36, and then x would equal 18, all right, so there is the answer there. If you really wanted to write it out really specifically, you could say f of 18 is equal to 1/12. That gives you the full function notation, all right? And then lastly, the bottom example here, find x if h of x is 4. Well, again, h of x is 2x squared minus 4, and that's going to equal 4. Okay, now I got to solve this equation for x. Okay, now I have over here the order of operations, which I used earlier on part D, and I went, when I had the value, I went and solved, and I followed PEMDAS exactly. When you are trying to solve x or isolate x, I'm trying to get x all by itself. When your instructions are to then solve for x, you want to work PEMDAS in the inverse order from the bottom up. So I want to start with s. So I kind of want to do SADMEP. All right, so I'm going to start at the s and work my way up when I am solving. So I first want to get rid of addition or subtraction. Okay, well, to get rid of addition or subtraction, I can simply add the 4, and I add 4. And now that's going to become 2x squared equal to 8. All right, I've done addition and subtraction. Now I want to get rid of multiplication or division. What's the multiplication? I have a 2 there, so I'm going to divide by 2, divide by 2. And now I get x squared equal to 4. So I've done the division, multiplication, division. Now I want to get rid of exponents. Okay, what's the exponent? I have an exponent of 2. How do you get rid of the exponent of 2? I will take the square root. Square root. And then that gets me x is equal to what? And I bet you most of you are going to say the answer is 2. But that's only half right. Remember, whenever you take a square root, it's got to be plus or minus 2 is the final answer. All right? And there were no parentheses, so I didn't have to do that. So again, solving equations, I go backwards through the order of operations. If I know a value, I go through the normal order of operations. That's the difference. Last thing here, using function notation and using it on a graph. So here for number 1, all right, it's just simply find f of negative 1. Okay, which means I know that x equals negative 1. I'm trying to find y. All right, I don't like where I put that, so I'm going to erase it. All right, so again, x equals negative 1. So here's negative 1. What is the y value right there? Well, the coordinate at that point, that's negative 1 comma 0. So what's the y value? The x is 0, or y is 0. So there's the answer there. F of negative 1 equals 0. For part B, f of 0. That means x is 0. Find y. So when x is 0, the graph is right up here. So there's the coordinate 0, 4. So then f of 0 is equal to 4. So moving on to part C, find x when f of x equals 0. So if f of x equals 0, that's like saying y equals 0. So I want to know, where does y equal 0? Right there. Well, what's x? Well, I have there, 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 and there. So I actually have 4 answers. So x would be negative 2, or negative 1, or 1, or 2. So I have 4 answers on that question because there are 4 spots where the graph is y equal to 0. On part D here, find x when f of x is negative 2. So where is it at negative 2? All right, well, let's just pretend that my graph was perfect. I meant it to be right there. So I want that point and that point, all right? So let's pretend that that's what it was. There's a coordinate of something, comma, negative 2, and over here is a coordinate of some number, comma, negative 2. Well, let's pretend it's a perfect graph, all right? And it's exactly, that's negative 1, negative 2. It's exactly negative 1.5, and here it's positive 1.5. So in this case, x is equal to negative 1.5 or positive 1.5. I don't like decimals, but I would accept if you wanted to write it as an improper fraction. That is better, or just the same, but whenever possible, use a fraction. This is then your homework assignment for this lesson, and I have in the slides, I have a homework assignment attached to the notes, so you can print it off and work on them yourself, or you can use a textbook and your own piece of paper. All right, good luck on that.